Welcome to week 6, pre-calculus. Hope you guys are all doing well. I can't believe we're getting really close to being finished with school. Hope you guys are getting started on your reviewing for your final exam, in between studying for your AP tests, and of course doing all your other work. Oh yeah, you guys got a lot going on, don't you? Okay, I'm going to stop babbling and get going here on 10B. We're going to continue looking at our vectors, and we're going to focus on what's called the dot product. So we already looked at adding our vectors, which would keep adding vectors is like keeping track of growth in several vectors altogether. And then we talked about multiplying by a constant or a scalar. And so essentially that would be making a vector stronger in this as it goes in the same direction. And now we're going to focus on what's called the dot product, or multiplying two vectors together. And it's applying directional growth of one vector to another. And so the result of a dot product is going to be keeping track of how much stronger we've made the original vector. And so that strength actually can be positive, negative, or it can be 0. Okay, so you're going to keep all that in mind, I'm sure, as we're doing this. Just also keep in the back of your mind as we're going through all the mathematical part of it, that in physics we use vectors for engineering, with surveying, astronomy. We can use them for, like, you see solar panels on the top of houses now for power. So solar rays are absorbed by a panel. That's we can study that using vectors, or measure it with vectors. So there's a lot of applications for this, and possibly you've been looking at, or you seen vectors in your physics class. But we're just gonna, of course, look at it mathematically. When we are calculating the dot product of vectors, multiplying two vectors together, we essentially are we're going to multiply the x coordinates of our vectors, and then multiply the y coordinates, and then add them together. And our result is going to be a number, not a vector. So just keep that in mind. It's the result's just a number, because it kind of represents the strength. How much stronger do we make the vector when we applied another vector to it? That's in general kind of what it is. So we are going to first practice dot product here, multiplying our two vectors together. It says find the dot product of u and v, but then we have a and b listed as our vectors. So just be patient with us on this. So again, we're going to multiply, when we do the dot product or multiply two vectors together, we actually multiply the x coordinates together. So we're going to multiply the 3 times the negative 5. And then we're going to multiply the y coordinates together, so the negative 2 times the 1. And then we add their products. So you multiply and then you add. So we'd have negative 15 plus negative 2. And then we add those together and we get a negative 17. And remember, this is a scalar number, not a vector, because it's representing the strength-ish. Okay, so you try B, pause the video, try it on your own, and then check your answers. Okay, take a minute, check your answer, or a second, whatever, check your answers. And then we're going to move on to using our dot product to find the magnitude. Or remember, our magnitude represents the length of our vector. So on the previous day, a week's notes, 10A week, that week notes, we saw this formula, but we didn't use it. And so now we're going to use it. And essentially it's the Pythagorean theorem. It's your a squared plus your b squared, and then you square root. So to get the magnitude or the length of our vector b, we would square our 12, so our x-coordinate, and then square the 16, the y-coordinate, add them, and then square root. Yeah. So remember, this is our component vector when we're given b as a vector 12, 16. The component vector, so essentially it's at the origin, and then going in a direction is telling us the direction from the origin. So we can really just skip like on example 1 up above where we had 2 vectors, we can skip in this example our second vector because those would be zeros, the origin vector. If you wanted to know all that background information. So we're squaring the 12, we're squaring the 16, which I can't remember what that is. I should. I want to say 256. It is 256. Yay! And then we're going to add them together. And then square root. Lovely number 20. So pause your video, try B. Okay, check your answers. Remember the square root of 50 is 25 times 2, and we can square root 25 and get 5, but the 2 can't be square rooted without getting a decimally answer, and so we end up with 5 times square root of 2, or if you want to go approximate instead of exact, then you would type that in your calculator. All right, moving on. Another fun thing we can do with vectors is we can find the measure of the angle between the 2 vectors. So if we had our 2 vectors, for example, one going that direction, the other one going this direction, and we wanted to know what angle we have between those 2, we could calculate it. And we've got this fancy formula here where the cosine of our angle is going to be multiply our 2 vectors together and divide it by the magnitude of our 2 vectors multiplied together. So we're going to break this down. There are several different formulas for this out there. This is just one of them. So I could go through all the other formulas if you cared, but I'm just going to assume that you guys really don't care. So I'm just going to go through the process, and I have to remember too that in the end I want to find my answer to the nearest 10th of a degree. So starting with our process, we want to first multiply our 2 vectors together. Oh, you don't want to use yellow. So I'm going to take A and I'm going to multiply it by vector B. And if you remember, that's the dot product that we were just doing on the previous page. So I would take my x-coordinate of -5 and I would multiply it by the x-coordinate of B, which is 4. And then I'm going to add and multiply my y-coordinate of vector A times my y-coordinate of vector B. So I'm going to simplify that, multiply my x's, and multiply my y's, add them together, and I'm going to get -28. Okay, so that's going to be the numerator that I'll use to find my angle. Then to get my denominator, I need to find the magnitude of my vectors. So I'm going to start by finding the magnitude of vector A, and I'm going to use essentially the Pythagorean theorem for this. So I'm going to take my -5 and square it, and my -2 and square it, add those together, and then square root. So you can always, of course, use a calculator. So I'm going to get square root of 29. And I don't want to take the time to type that in my calculator because I don't need to right now. So I'm going to do the same process with vector b. I'm going to find the magnitude of vector b. And again, I'm just using my Pythagorean theorem. So I'm going to take the x-coordinate, which is 4, square it. The y-coordinate, which is 4, square it. I'm going to add those together and then square root. So I'm going to get 16 plus 16, or 32. So I have the square root of 32. So that's my denominator. That's going to be part of my denominator. Okay, so now I'm going to put all the pieces together to get my cosine. I'm going to start by saying this is the cosine of theta. So I'm going to use the negative 28 as my numerator. And then I'm going to multiply the magnitude of vector A, which is square root of 29, and the magnitude of vector B, which is square root of 32. Multiply those together, and then that's going to be my denominator. So I type all this in my calculator, negative 28 divided by the square root of negative 29 times the square root of 32. Be careful about it when you're typing this in your calculator. Put parentheses around your denominator so the calculator knows everything that's in the denominator. And you should get negative 9191 approximately. 0.9191. And then we have to use the inverse cosine because we want to know what the angle is. Remember when we did that a little bit ago? So then you already have your decimal number on your calculator. You just type in second cosine, and then I would push second negative to use my answer, so I don't have to type that in. And you should get about 157 degrees, or which is in the printed notes. But it asks us for the nearest tenth, so it really should be about 156.8 degrees if we were following the directions. Okay, go ahead and pause the video and work through example B, or example 3B, and then check your answer. Okay, go ahead and check your answers, your work. And again, remember on the Google Classroom, we still have the worked out notes as well, so that you could use those if you don't want to hear my voice. I don't know why you wouldn't want to listen to me, but just in case. All right. So there's a cool thing. Oh my gosh, I haven't used this word in so long. I'm so excited. Vectors can be perpendicular to each other, of course. They could be going in 90-degree angle directions. And so essentially, if that is happening, then their strength, they're not making each other stronger. Like one's going north and one's going east. They're perpendicular to each other. They're not making their strength stronger, essentially, whatever, in general. So that's called, so if their strength is 0 or their dot product is 0, then that's called orthogonal because they're perpendicular. So sometimes our vectors can be perpendicular to each other, and with vectors we call that orthogonal. That's our new word. It means perpendicular, orthogonal. So exciting. I haven't used that word in so long. Love it. So one way to check to see if our vectors are perpendicular or orthogonal to each other would be to check that their dot product equals 0, meaning no strength, I guess. So this example 4 is on your quiz. There's one just like this on your quiz, but there's not any like this on your worksheet. So you're still using the dot product, so that part's not different, but we are going to trying to find a missing coordinate here to create this orthogonal situation. So we're going to still multiply our x coordinates together, so my negative 2 of my x coordinate of my A times the negative 2 x coordinate of my B. and plus my y coordinates multiplied together, so my -1 times k. And to create an orthogonal pair of vectors, their dot product has to equal 0. So we want to multiply our vectors together, we get a 0 dot product. So we're going to solve this for k to create this situation. So that's our goal here. So multiply my 2's together, multiply my -1 times my k. I'm going to subtract my 4 over. I'm just solving now. I've got just an algebra problem. Subtract my 4 over, divide by -1, and I get k equals 4. So we're just using our dot product to create an orthogonal situation. Again, on your quiz, not on your homework. Make sure you look over that. Take the time to make sure you understand it. And finally, we've got ourselves a application problem, which I know you guys have just been dying to see. Again, this is pretty simplified. We're not going to do it like full physics style where we include gravity. We're totally ignoring gravity in this situation, so you'll have to refer to your physics teacher for more details. When we're looking at an application of vectors where we've got work done by a force. So we've got a force and it's acting on an object to move it from one point to another. Then in our formula here is that we're just going to multiply our magnitudes of each vector together. That's going to give us our work. That's very simplified. Okay, see, you've got your steps over on the side. We're going to go through these steps. So we have a force of 80 pounds on a rope. So we're using a force of 80 pounds to pull this box up the ramp. And the ramp is at an angle of 10 degrees. And we're pulling from an angle of 35 degrees. So this 35 degrees is that angle. The 10 degrees is the angle of the ramp. And we're trying to figure out how much work it's going to take to get that box 24 feet up the ramp in this situation. So our first step is we want to take the ramp out of the situation. So our angle that we're going to use is 35 minus 10 because we don't want to deal with the ramp, if that helps. And on your quiz, by the way, you won't have to deal with the ramp. The ramp won't be there, so you won't have to do this little step. So this gets us back to level. So now we're going to do the second step is we're going to find our force vector. And we did this in 10A. So we're going to take our 80 pounds of force that we have, and we need to find the vectors. So we're going to multiply the 80 times the cosine of our angle. That will give us our x-coordinate of our vector. And then we multiply 80 times the sine of our angle. And that will get us the y-coordinate of our vector. Type those in your calculator, and we're going to get about 72.5 for our x-coordinate of our force vector, and then about 33.81, I can't write an 8 today, for the y-coordinate of our force vector. Now we're going to find the other vector, and this is going to get us our distance. So we're going the distance vector AB. And we're told that we want to go 24 feet along the ramp. So our vector AB is going to be 24 feet along the ramp. So to get the work, how much work do we have to do to get this box up the ramp? We're going to multiply our vectors together. So we're going to take our force vector and we're going to apply that or multiply it by the distance that we're trying to go. So we've got a force times our 24, 0. And so remember, dot product, we're going to multiply our x's together. So that's about 72.5 times the 24. And then we multiply our y vectors together. And I'm laughing to myself because we're multiplying times 0. So really you don't even have to do that step. So really, some of you are going to find the shortcut. You're just going to start with your distance, and you're going to multiply by your force times the cosine of your angle. But it might take you some practicing to figure that out. I know you can do it. I have faith in you guys. We're going to get about 1,740 foot-pounds is how much work it'll take to get that box up the ramp. So about 1,740 foot-pounds of work to get the box up the ramp. Yes, we did it. I'm so proud of us. One more lesson down. So make sure you're practicing all these steps. Work through the worksheet. There's 13 whole problems on there. You guys can do it. Meet us in Google Meet. We'd love to see your face and give you any help that you need, and hope that you're staying safe and healthy. And remember, we miss you guys. Talk to you soon. Bye.